Priti, lots of things are electronics components there are there, and they are using op-amps. Okay, and not only op-amps, transistors, all of things are also there, but op-amp is also a vital thing. Okay.
Can you repeat the definition?
Yeah, I'll definitely repeat. Just wait. So this is how an op-amp looks like. Okay, and this could be another op-amp. So write down, an op-amp is a circuit that can perform. An op-amp is a circuit that can perform mathematical expression. Sorry, mathematical operation like addition, subtraction, integration, differentiation, etc. Which book you are following for this electronics? Anything? Ma'am, কিছু suggest করেছেন?
Ma'am,
Sorry, Biman. Hello.
ম্যাম বয়েল স্টেটের বই নিতে বলছে।
Boyle state, হ্যাঁ Boyle state best. Boyle state নিয়ে নাও. It is very good. In fact, it is available in your library. Lots of copies are there. That is available in your library. I am having this book also. If you want, I can just take a PDF. I mean, I can just take a snap and I can send. So, definition part done. Have you written that?
yes, ma'am.
Okay. Now, this op-amp is basically a multi-stage amplifier. Okay. It has so many stages, and the main important stage is called differential amplifier. Okay, DA. In short, we will call that DA, and that is full form is differential amplifier. And the last stage is a class B push-pull power amplifier. When you will study power amplifier, you will know what is class A, class B. So basically in op-amp, the last stage is power amplifier, and that is also class B power amplifier. I don't know who is going to take that part, me or them, but that is the last part. And in between, lots of stages are there. That is gain, voltage gains, okay. And the main thing of an operation amplifier is differential amplifier. This is the most important thing. So write down, just change the para and write down. It is basically a multi-stage amplifier. It is basically a multi-stage amplifier. Give a comma and write down. And the stages are differential amplifier, input stage, followed by sorry, followed by high gain C amplifier. Intermediate state অনেকগুলো CE amplifier থাকে, that is common emitter amplifier, that is BJT. CE means BJT. Okay, common emitter type amplifier.
ম্যাম ফলোড বাই এর পরে একবার রিপিট করবেন, বুঝতে পারলাম না ঠিক।
Yes, followed by a high gain, GAIN gain,
ম্যাম
high
ক্যান ইউ রিপিট
gain.
আফটার ফলোড বাই?
Yes, after followed by I'm repeating. Acha, I'm repeating the entire line. Differential amplifier input stages followed by a high gain CE amplifier. A high gain CE. C and E both will be in capital. A high gain CE amplifier and finally the output stage. And finally the output stage. And finally the output stage. Full stop. In the next line, write down the main electronic circuit in an op-amp is the main electronic circuit in an op-amp is differential amplifier. In bracket, write down capital D, capital A, and underline that portion. The main electronic circuit in an op-amp is differential amplifier, and underline that particular portion. Done?
ইয়েস ম্যাম।
Now let us write down the usage. So write down an op-amp is an IC or integrated circuit used in computers as video and audio amplifiers in communication electronics. An op-amp is an integrated circuit or IC used in computers or as video and audio amplifiers in communication electronics. Um, I am I have made this PPT from by taking some of the points from Boyle State and some of the points from Weekend Mehta, Rohit Mehta. That's Mehta and Mehta and Basic Electronics is also a very good book. Very good book if you want to just study, because Boyle State is a little bit, I mean, that is also a very good book, but that is little bit, I mean, that is in very details, and that is, I mean, little bit, it will be tough for you. Okay. But if you at first study VK Mehta, Rohit Mehta, which is obviously not available in your library, and then start studying Boyle State, it will be easier for you. Because Mehta and Mehta, languages are very easy. Okay. So whatever book you are taking, either taking from library or by just at first just have a look, just read once. If you are if you are okay with it, then take it or buy it. Okay, so one more thing, that is op-amp. This point, this particular um, um, topic is very very important. If you are planning to get or maybe you are planning to give next. This one you can also write. They are both used in linear circuits, also in digital circuits. And this is the circuit. This is the circuit diagram or basic diagram of an op-amp. Draw this way. Plus symbol, that is input 1, minus input 2, and this one is out. You can exchange the minus plus symbol, not a big deal. But this is the basic symbol of an op-amp. Draw this, then we will proceed. So tell me if you have any doubt in here. Any doubt? You guys draw this one. Meanwhile, I'm just repeating. Just listen, hear me out once. So op-amp, that is an operational amplifier. Why it is called operational amplifier? Because it is basically this type of amplifier are able to do all kind of mathematical operations like addition, subtraction, integration, differentiation, all of this. That's why that they are called op-amp. Where they are used? They are basically used in computers, in computer IC chips. Okay. Apart from that, they are also used as video and audio amplifiers in communication electronics. Both in digital and linear circuits, they are used. Done. Next, the basic op-amp is basically a multi-stage amplifier where the primary stage is called, or the main stage is called DA, that is differential amplifier stage. And the last stage is basically a power amplifier. Okay. So till here, do you have any doubt? Anyone you can ask. Or if you have anything to ask, you can ask. Is there anyone who is who want to ask anything, or still there is any doubt, anything? If
No,
yes,
ma'am.
go ahead. Not yet. Okay, fine. Then let us move to the second part. See, this is the you have to draw this diagram. Now, after this op-amp will work in two different operations. Number one is called single-ended operation. Number two is called double-ended operation. So this is actually single-ended operation. Why this is single-ended operation? Now see this, two input terminals are there, and see this negative terminal is basically here grounded, and we are giving the signal in the positive terminal, and we will give very minor signals. Okay, though we are electrical engineers, but while you are handling any electronics component, okay, their maximum voltage, it, it can withstand hardly 5 volt, hardly. Okay, so we will apply we will apply minimum voltage or minimum signal. So we are giving in the input side a minimum signal, and you can see from this figure, while we have applied the signal in the positive terminal, we have given the output is also in same phase. See, just compare both the signals. Output is also in same phase, but it is magnified. Am I clear? Output signal and input signal both are in same phase. There is no change. Both are in same phase and it is magnified. So this one is the outcome when you are giving the signal to the positive input. Okay, next. Now the positive terminal is grounded. Okay, and we are giving the signal to the negative input. And what is going on? At that time, we are getting also a magnified signal, but it is 180-degree out of phase. Okay, or it is reversed. See, here the signal is in this way, and here it is totally 180-degree out of phase. And this is called single-ended operation. Why single-ended operation? Because we are taking just one particular input. Another input is our grounded. Is that clear? বলো জায়গাটা ক্লিয়ার হয়েছে কিনা? Or do you have any doubt? You can ask.
I mean, the second
This
one,
is
why it is reversed?
second one.
Why the output is reversed?
Why the output is reversed? Because we are giving the signal in the negative terminal. See, while
Yes.
you are giving the signal in the negative terminal, then it will be reversed. আর সেটা বোঝার জন্য we will discuss DA, the mathematical basic operation of differential amplifier, because inside this op-amp lots of DAs are there. Okay, and this is the for now, just try to understand whenever you are giving a signal to the positive terminal, and actually we will call that non-inverting terminal. Okay, at that time, your signal output signal will be magnified, but it will be on same phase with the input signal. But when you are giving the signal to the negative terminal, or we can call inverting terminal, at that time the output signal will be same, that will be also magnified, but 180-degree out of phase. So write down. At first write down single-ended input. Don't have you drawn this?
No,
Yes,
ma'am.
ma'am.
Okay,
No.
just okay, fine. Now at first write down single-ended input. Now write down this type of operation results. This type of operation results this type of operation results when the input signal is connected to one when the input signal is connected to one input with the other input connected to the ground. So this type of operation results when the input signal is connected to one input with the other input connected to the ground. Okay, and then draw this two. Okay, please be focus. Be particular with the signal drawings. Okay, take a scale. Do not hurry. Take a scale and pencil and then draw it. Is that done? To do it once it's done, let me know. Okay.
Ma'am, so here basically AC input is preferred, right?
So basically,
Ma'am, I meant basically what type of input is preferred for.
that is depending upon your desired output. What type of output we want, depending upon that, we will give the signal on particular that input. Okay. Okay.
Okay.
But op-amp is basically sometime, in maximum time, it will work on double-ended input. After that, we will study that case. Okay. This one is single-ended, where we have taken only one input side and another one is grounded. But maximum time op-amp is working on double-ended input. Okay. Just to say, show you what is double-ended. This is double-ended input. Okay. The students, all of you, all of you are done with the single-ended input, single-ended operation.
Yes, ma'am, guys.
Okay. So this is actually a double-ended operation. Okay. Why? Both the inputs we will take and we will give the signal, and inside this op-amp there is a differential amplifier which will amplify the difference between this signal. Okay, I mean in plus symbol and in minus, in between this we have given a symbol, we have given a signal, and it will amplify obviously, but the difference between these two it will amplify. See, VD, this is the difference. Either you can give in this way or you can give in this way also. Suppose you are giving V1 over here and V2 over here. Now we don't know what will be the nature of this. If your V1 is larger, if the signal, whatever we are giving over here, if that one is larger, then obviously it will be in phase with this V1. And if the value of V2 is larger, then obviously at that time, the output signal will be out of phase with the signal. Are you getting me? Suppose V1 and V2, we are giving, signal that is in this shape, okay, but the values are little bit, suppose voltage values are little bit higher in V2 and lower in V1. So obviously our output voltage will be out of phase with this input signal. But if you are giving V1 larger, then this output voltage will be in same phase with the V1. Whatever value you are giving larger, that particular nature will be dominant. That's it. Clear, or do you have any doubt? Ask me.
Clear, ma'am.
Okay, so now give a heading, double-ended input. Double-ended, or in bracket write down differential. It is written over there. Double-ended, or in bracket write down differential input. So write down in op-amp, it is entirely possible to apply. In op-amp, it is entirely possible to apply signal at each input signal at each input. This is called double-ended operation. This is called double-ended operation. Full stop.
Can you repeat the definition?
Yes. In op-amp, it is entirely possible to apply signals at each input this is called double-ended operation. In this figure, just write down, after that you can draw the figure. In this figure, V is applied, VD, this VD, okay? This VD. In this figure, VD is applied between the two terminals in this figure, VD is applied between the two terminals and we will get the resulting amplified output, and we will get the resulting amplified output in the output terminal. Resulting amplified output in the output terminal.
Can you repeat after we will get?
We will get the resulting amplified output in the output terminal. And then draw this. Once you are done, let me know, okay?
Ma'am, what about the input and output of the second one?
Do not, you don't need to draw it, because this entirely depending upon which will be the dominating, okay? Which one
Okay.
will be the higher. Like here, they have assumed that maybe the positive signal is higher, so that's why they have taken the output signal is in the same phase with the input. Hello,
Yes,
am I
ma'am.
audible? Okay. Now, this is the block diagram, or you can say basic stages of an op-amp. Okay. You can see this one is input terminal, this one is output terminal. And what are there? As I told you, a differential amplifier, some stages of gains, lots of gains will be there. Gain means simple voltage gain. Okay. And this one is the last part is class B push pull emitter follower power amplifier actually. Okay. So these are the stages of a op-amp. Just draw it and then I'm explaining this. At first draw it. The input stage of a DA, I'm just using the short form DA. DA means differential amplifier. Okay. The input stage, the input stage of an op-amp is a DA, and the output stage, the input stage of an op-amp is a DA, and the output stage is a class B push-pull emitter follower. Number two, the internal stage of an op-amp are directly coupled. The internal stage of an op-amp are directly coupled. give a comma and then write down no coupling capacitors are used. The internal stages of an op-amp are directly coupled. Give a comma. No coupling capacitors are used. The direct coupling allows the op-amp
Ma'am, direct coupling.
yes, direct coupling, coupling. There is no coupling capacitor. Capacitor থাকলে কি হবে? It will only work in AC. It will not work on DC. সেজন্য capacitor use করা হয়নি. They are directly coupled so that they can use, I mean, an op-amp can be used both in DC as well as AC. So the direct coupling allows the op-amp to amplify DC signals as well as AC signals. Okay. Done. Point number 3, very, very important. Point number 3. Op-amp has very high input impedance, ideally infinity, and very low output impedance, ideally 0 in bracket. So write down, an op-amp has very high input impedance, in bracket write down, ideally infinity. If your infinity is your input impedance, current will be 0. Okay? If the current is 0, zero current draw করছে, and output impedance, if that is 0, that means large number of current will be there in the output side. Okay? This is for ideal case. Practically, in an op-amp, input resistance is almost 20,000 ohm. Okay? Output resistance is very less, like 5 ohm or 6 ohm, like that. Okay? So an op-amp has a very high input impedance, in bracket write down ideally infinity, and very low output impedance, in bracket write down ideally 0. The effect of, continue with that point, okay, after full stop write down. The effect of high input impedance is that, the amplifier will draw a very small current. The amplifier will draw a very small current. Achha, this is the basic characteristics of op-amp also. Okay? If you get any question in your exam, what is the basic characteristics of op-amp, you have to write this. The effect of high input impedance is that the amplifier will draw a very small current from the signal or from the source signal full stop. The effect of very low output impedance is that The effect of very low output impedance is that the amplifier will provide a constant output voltage. The amplifier will provide a constant output voltage independent of current. Independent of current. The amplifier will provide constant output voltage independent of current. Next. It has very high open loop voltage gain. Write down. An op-amp has very high open loop voltage gain. An op-amp has very high open loop voltage gain. In bracket, write down. Ideally infinity. Ideally infinity. Give a comma and then write down. Give a comma and write down. Typically more than 2 lakh.
More than
2 lakh.
ma'am, can you repeat?
An op-amp has very high open loop voltage gain. In bracket, write down ideally infinity. Give a comma and then write down typically more than 2 lakh. 2 and then 6 zeros are there. Op-amps are, next point, op-amps are always operated with negative feedback. Op-amps are always operated with negative feedback. Because it includes large bandwidth and gain stability. Because it includes large bandwidth and gain stability.
Ma'am, can you please repeat again?
Op-amps are always operated with negative feedback. Op-amps are always operated with negative feedback. Because it includes large bandwidth, BAND, band, WIDPH. This is the spelling. Bandwidth and gain stability.
Ma'am, what stability?
Gain stability, GAIN, gain. That is voltage gain. Last point. Very high CMRR, common mode rejection ratio. That is a point we will discuss later. For now, just write down very high CMRR. In bracket, write down greater than 90 decibel dB. Small d, capital D. Very large CMRR, a very high CMRR. In bracket, write down greater than 90 dB or greater than 90 decibel.
Ma'am, can you please tell the full form of CMRR?
Yes, common mode rejection ratio. Common mode rejection ratio. That is the full form of CMRR. So these are the characteristics of op-amp. This is the basic state, the block diagram of op-amp, how op-amp looks like basically. Okay. So just do one thing. If you are done, just take a rest for 5 to 7 minutes. After that, I'll be done. Okay. Don't leave the class. So this is the basic nature of an op-amp. That is the input resistance or input impedance should be very high, output should be very low. Okay, as low as it could be, and then an op-amp will always work on negative feedback. Achha, its open loop voltage gain will be very high, CMRR will be very high, and stages are differential amplifier and class B push-pull amplifier. Okay. Next. Now, this is the schematic diagram of an op-amp. From this figure, here you can see there are two input and one output. So you can say that this one is a three-terminal device. But actually, an op-amp is a five-terminal device. 1, 2, 3, and this two. These two are voltage terminals. One is positive, another one is negative. Basically, it will work up to minus 15 to plus 15 volt, and that's why these two are almost balanced. That's why these two we usually do not draw, but this is the actual diagram of an op-amp. And as you know, the negative input that is known as inverting input, and the positive input that is known as non-inverting, and this is the output. So draw this schematic diagram of op-amp. If you want, you can draw this too, or this one is important. Draw this. Drawing done?
Ma'am, 1 minute, ma'am. Just one.
Okay, okay.
Ma'am, any specific reason as to why the terminals are reversed?
Which terminals are reversed?
Ma'am, the positive and the negative, the input terminals.
No, just there are two. There are two inputs. While you are giving signal to any particular input, and if the output is giving you the same, if the phase are same, that is non-inverting. Okay, and we will denote that with positives because there the phase is not changing. Okay, and if in a particular input, if you are giving a signal and you are getting a signal which is out of phase, then that will be your inverting. Okay, and we are just for our identification, we are giving this negative terminal. It doesn't mean that positive terminal or negative terminal. No, it's just inverting terminal and non-inverting terminal. Okay, like in battery, we know positive, negative terminal. Okay, it's not like that same. It's just inverting. We are denoting inverting with negative term and non-inverting with positive term. Got it?
Yes, ma'am. Thank you.
So write down the basic op-amp has 5 terminals. Just give Roman 1 and then write down. The basic op-amp has 5 terminals. For supply voltages, the basic op-amp has 5 terminals. Okay, give a colon, not semicolon, colon. 2 terminals for supply voltages, plus V and minus V. 2 terminals are for supply voltages, plus V and minus V.
Can you repeat?
Bolo.
Can you repeat what you just said?
Yes. The basic op-amp has 5 terminals. Give a colon and then write down. 2 terminals for supply voltages, plus V and minus V. AJ Gupta. 2 terminals are for supply voltages, plus V and minus V. Give a semicolon and write down 2 input terminals, inverting and non-inverting. 2 input terminals, inverting and non-inverting. And 1 output terminals. Acha, this is actually op-amp, with 5 terminals. But jodi dekho, actually in op-amp there are 7 terminals. 2 more terminals are there. Eta bracket e likhe rakho. For exam purpose, you do not need to write this, but for your information, actually op-amp has 7 terminals. 5 terminals here I have explained. 2 more terminals are there. That is called offset null terminal. Okay, and they are basically used for DC when you are giving a DC signal. Okay, so just with that point, give after this part, give a bracket and write down NB and then write down 2 other terminals two other terminals in op-amp are also present. And that is called offset null terminals. OSSET, offset null and NULL null terminals. Now you may ask, what is offset null terminal? Basically, ki hoy in op-amp, if you are giving same input into in this input, I mean, suppose you are giving same values of signals in both inputs, okay, then the output will be 0. Suppose you are giving 5 volt in the inverting input and 5 volt in the non-inverting input also. So 5 minus 5. This 5 is positive, non-inverting 5. And there in inverting you are also giving 5, but that is negative. Negative symbol is there. So 5 minus 5, because the signal ta opposite hoye jabe, ulte jabe. So it will be cancelled out. They will cancel each other and the output will be 0. Okay. Now to ensure this 0 output, these terminals are used. That's why they are called offset null terminal. Okay. বোঝা গেল আমি কি বললাম এক্সাম্পলটা, or shall I repeat?
Ma'am, please repeat once more.
Suppose you are giving a signal in the non-inverting input 5. Okay, 5 volt. Similarly, you are giving the same input in the inverting input. Inverting terminal same picture, 5 volt. But while you are giving in the inverting, that will be changing. It will be 180 degree out of shift because that is inverting input. So what is going on? Positive and negative, they will, values are same, magnitudes are same. Now the directions are opposite, so they will basically cancel each other. This two signal is basically cancel each other, and in the output terminal you will get 0 voltage. Theoretically, এটা পরে পড়বো আমরা what is offset null, but practically you will get very less, I mean minor voltage, very less, which is negligible, which is almost same as 0. So this one is called actually offset null voltage. Okay, এটা আমি পরে আবার রিপিট করব বিকজ এই কোশ্চেনটা তোমাদের আবার পড়াতে হবে। স্টিল মনে রেখো এই যে অফসেট নাল টার্মিনালস জাস্ট রাইট ডাউন, তখন দরকার পড়লে আমি এখানে আবার আসবো। Two terminals, the offset null terminals are used. ঠিক আছে, the offset null terminals, they are used to ensure 0 output. They are used to ensure 0 output they are used to ensure 0 output when the two inputs are equal. When the two inputs are equal. Actually, to understand this, you have to at first read through the DA characteristics. After that, we বুঝতে পারবো কেন আমরা same signal দেব না, and what is the meaning of the CMRR, common mode rejection ratio. Then we will again repeat. Don't worry. Okay, number 2, write down. The minus and plus symbol of the input side, the minus and plus symbol of the input terminals, write down. The minus and plus sign of the input terminals indicating the minus and plus symbol of the input terminals are indicating inverting input and non-inverting input. আমি কিন্তু আবার বলছি, they are not indicating the polarity like battery. This negative and positive symbol in the input and input terminals, they are just indicating the inverting and non-inverting characteristics of the input. It is not the polarity. Battery or switch এর নেগেটিভ পজিটিভ সিম্বলের সাথে এর নেগেটিভ পজিটিভ সিম্বলের কোনো সম্পর্ক নেই। Are you getting me? Are you getting me?
Yes, ma'am.
So again I'm repeating, just look once. The minus and plus symbol are indicating the inverting input and non-inverting input of the input terminals. Okay, so basically if you are giving a signal in the non-inverting input, the output will be in same phase, obviously magnified, and if you are giving a signal in the inverting input, the output signal will be 180 degree out of phase, but it will be also magnified. এটা মাথায় পরিষ্কার ঢুকে করো। Last, number 3 is V1, V2 and V output. These are the node voltages. Write down V1, V2, V output. This V out, okay, this out will be in suffix. V1, V2, V output are node voltages. তার মানে কি? This means they are always measured with respect to ground. এতটা done? So the basic op-amp has 5 terminals. 2 offset nulls voltages also there, but আমরা এখন সেটা দেখছি না। Basically the basic op-amp has 5 terminals, 2 input terminals, 1 output terminals and 2 voltage terminals. Done. Next, the negative and positive symbol or sign in the input terminals, they are just denoting the inverting and non-inverting characteristics of the input, not the polarity. Okay, V1, V2 and V output, these 3 are the node voltages. Always we will measure these 3 with respect to ground. Clear? Up to this clear?
Yes, ma'am.
Ma'am,
Follow.
ma'am, can you just
follow.
can you just definition দিতে পারবেন? মানে
কিসের
proper
definition?
definition. Inverting or non-inverting input.
Inverting and non-inverting. Yeah, definitely. Write it down then. What is inverting and what is non-inverting input. Okay. So write down inverting input. At first give a heading and write down while we are giving any signal. Sorry, just write down in this way. A signal applied to the terminal A signal applied to the terminal and if the output gives and if the output gives 180-degree out of phase of the input signal, and if the output gives 180-degree out of phase of the input signal, then it is called inverting input. After writing it, please let me know. কি লিখলে? বা আমি কি বললাম? Completing the
And
sentence.
it is called
It is called inverting input. Ma'am, someone please read it out once.
A signal applied to the terminal, and if the output gives 180-degree out of phase of the input signal, then it's called an inverting of input.
Right. Yes, someone was asking something. Yes, is there anyone who is asking something? Okay. So for the non-inverting terminal, just write down a signal applied to the terminal a particular terminal input terminal. Okay. A signal applied to a particular input terminal gives an output signal in same phase with the input signal, then it is called non-inverting input. In same phase with the input signal, then it is called non-inverting input. ব্র্যাকেটে নন ইনভার্টিং এর পাশে একটা প্লাস সিম্বল দিয়ে দাও আর ইনভার্টিং এর পাশে একটা নেগেটিভ সিম্বল আর মাইনাস সিম্বল we are denoting by this two plus and minus. So done. Now, before going to study op-amp in details, you have to understand what is DA, because as I have told you and as you have read that, DA is the basic circuit of an op-amp. That is the differential amplifier. So what is this DA? From the name, you can understand that yes, it is some kind of differential things it will do, some kind of differential. What is that? The DA is such an amplifier which will accept two signals and it will amplify the difference between that two signals. Always. This is the basic, basic property of a DA. Suppose you are giving, now forget op-amp, just now focus on DA. Now, just a second. This is the basic circuit of a DA, differential amplifier. And this one is V1 and this one is V2. These two are the inputs, okay? And the output is V0, which is equal to A into V1, V2. A is the gain, voltage gain. So for now, I'm not focusing on A. I'll be focusing on V1 and V2 and the difference between two. Suppose you are giving voltage V1 at V1, suppose you are giving 7 volt. And at V2, suppose you are giving 5 volt. So your output voltage will be 2 into A. Whatever may be the voltage gain, if the voltage gain is 10,000. So 2 into 10,000. So your V output will be 20,000. So this is the basic property of a DA, that a DA will always amplify the difference between two signals, okay? And it will reject if the signals are same, okay? If you are giving same signal in both sides, suppose that is V1 is 5 and V2 is also 5, then V output will be 0. So this is the basic DA. Clear? At first tell me yes or no. Clear or not? Follow. That's why an op-amp always operates under differential mode. দেখো বোঝা গেছে কিনা? At first tell me. Tell me, আমি বুঝতে পারছি না তোমরা বুঝেছো কিনা?
Yes, ma'am.
So write down DA. What is a differential amplifier? Or just give a heading DA, and then write down an amplifier circuit that accepts two input signals. An amplifier circuit that accepts two input signals and amplifies the difference between these two signals. An amplifier circuit that accepts two input signals and amplifies difference between these two signals Such an amplifier is called differential amplifier. Such an amplifier is called differential amplifier. Draw this figure. At first draw this. This is the block diagram of this differential amplifier. First draw this one. Now, write down the block diagram of the figure shows the block diagram of a DA. After this diagram, okay, write down the figure shows the block diagram of a DA. There are two input voltages V1 and V2. There are two input voltages V1 and V2. And the amplifier amplifies the difference between these two input voltages. And the amplifier amplifies the difference between the two input voltages. Okay. And then write down, and the output voltage V0 is equal to A into V1 minus V2. Output voltage V0 is equal to A into V1 minus V2, where A is the voltage gain. That's it. Where A is the voltage gain.
And can you repeat?
Yes, বলো কোন পত্র লিখেছো?
And difference between the two voltages.
Therefore, and the output voltage is V0 is equal to A into V1 minus V2 after that. And the output voltage is V0 is equal to A into V1 minus V2. Where A is the voltage gain of the amplifier. Voltage gain of the amplifier. Today we will study up to this basic circuit of DA, and then the next class we will study. Tomorrow, do you have any holiday?
ম্যাম ঈদ।
ঈদ কালকে, পরশু না?
ম্যাম বুধবার তো
কালকে।
আমি জানি। কালকে, হ্যাঁ বুধবার কালকে।
Oh, then tomorrow you have a holiday. Okay, fine. Now next, basic circuit of a DA. Give a heading. Basic circuit of a DA. And then have to draw this. আচ্ছা, ড্রটা পরে করে নেবে, আগে শোনো আমি এক্সপ্লেন করে দিই। জাস্ট টেক আ স্ক্রিনশট। Basic circuit of a DA. Okay, you have to draw this figure. Either take a screenshot, or if you are having a laptop, then take a snap from your mobile. This particular figure. Now listen to me. This is the basic circuit, okay? And you can see there are two basic transistors. This is the symbol of transistor. এখন আমরা transistor পড়িনি, তাও আমি বলে দিচ্ছি। This is a transistor, this is a transistor, Q1 and Q2. Now these two transistors are identical. Okay. If you are taking CE configuration, I mean common emitter transistor, we will take two common emitter transistor. If we are taking common base, we will take common base transistor. যা নেব দুটো same transistor. Okay, দুটো same transistor always থাকে the basic circuit of a DA. Okay, and you can see there are here it is written E, that is RE, emitter resistance. This is VEE, that is emitter voltage. This is minus of VEE, emitter voltage, negative terminal. This is RC and RC2. RC1, this one is for this particular one transistor. RC1 is the collector resistance. And for transistor 2, RC2 is the collector resistance. Okay. Now, for transistor 1 Q1, this RC1, and for transistor 2 RC2, they both are connected, and then we are getting VCC, okay, that is collector voltage. Okay, two transistors are there, that's why C and C. Got it? Let me know if you are understanding the circuit or not. Two transistors are there. So base, one base is this one, input one. For this transistor, let us first focus on this Q1 transistor. This one is the base. A transistor always is three-terminal device, base, emitter, collector. So this is the base where input one is written. This is the base where input one is written. This is the emitter, and this is the collector. In the collector resistance, and then it is taken over here. From the collector terminal, we will take the output also. Collector is the output of a transistor. Okay, so from the collector terminal, we will take the output also. Similarly, this is transistor 2, where this is the base, okay, and this is the collector resistance. Similarly, we will take the output from this collector 2, and this emitter and this emitter, they are basically joined. What happened? Just a second. Are you guys able to see the screen?
Yes, ma'am.
Sorry. Interruptions. Okay, so these are the two collector resistors. They are connected and they are combined in a single emitter resistance. Okay, and that is RE. So this is the basic circuit of a DA, and you just have to remember that DA has two input using two transistors. Two transistors are there, so two inputs are there. This is the circuit diagram, this is the block diagram. Upper one is the block diagram, lower one is the circuit diagram. So two inputs are there, V1, V2. DA transistors are of same characteristics. Transistor will be always in same characteristics. Okay. Single ended and double ended, both operation can be possible. Just take any one, make that ground, and give signal to any particular one input. That will be single ended operation. And if you are taking both, it will be double ended operation. So both can be possible. Rest we will discuss in the next class. At the next class, we likhiyo debo. Just draw this part. I hope all of you have taken the screenshot. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Fine. So for now, I don't have your student list. I have to collect it from the class. Give me your attendance. Today is 20, right? Roll number 1,
Present, ma'am.
roll number 2,
Present, ma'am.
3, 4, 5, 6,
Present, ma'am. Ma'am, 5.
6,
Present, ma'am.
7,
Present, ma'am.
8, 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13,
Yes, ma'am.
14, 15, 16,
Present, ma'am.
I'm 15 present, ma'am.
16,
Present, ma'am. 16.
17, 18, ठीक है?
Ma'am, we have
16
till
অব্দি
16.
আছে।
Oh, up to 16. Okay, fine. Okay. বলো